All right. Welcome everyone to the second lecture of the BC106 cohort. This is the architecture of Dapp. This is our second lecture in a series of 4 to 5 lectures. So my name is Basil and I'm a coordinator at Blockchain Society. So the structure of this lecture would be first we will review the lecture one. Just a second. Right. So the structure of this particular lecture will be first we will recap the first lecture's concepts, and we will also look at the assignment and the assignments that you have submitted, and then we will move on to the architecture of a.
I think chat is ask them to do it on Q&A. Because that's knowledge in Q&A.
In Q&A.
That is not our case. So I don't have. This is a Q&A. You are also technical. But actually, get me actually technical way. That was good. And study to
Hello everyone, this is Manoj. I'm an executive in Blocksock, and welcome to lecture 2 of BC106. And now we are going with a quick recap. And before diving into recap, do you guys have any doubts or want to know anything beforehand? You can interact with us.
like please react.
Do you guys have any doubts? Okay, what is your doubt? So guys, if you're having doubts, put it in the WhatsApp group now. So we would be reacting to your doubts. Yeah, there is an option of injected provider MetaMask. It is not injected Web3, it is injected provider MetaMask. If you click on injected provider MetaMask, then it would redirect you to MetaMask and you can connect your MetaMask account to your Remix and you can send transactions from there. So did I clear your doubt? What particularly in contract? In the contract, you need to select a particular name of your contract. If your contract the name of the NFT smart contract would be something different. If you name it something else, it would be something different. It is contract ABB75AF0F2. The one which is in the bottom. Hiba Hi Barbie contract ABB75 AF0F2.sol is your contract name. So I hope it cleared your doubt. So whenever we are speaking about that, you can find the contract name in the topmost tab. After Pragma Solidity Cap 0.8.9, there you find Solidity logo over the tab, and there would be contract name .sol. So I think it will help you. Anyone else with doubts? So moving on to the next part, glance of lecture one and assignment one. What lecture one and assignment one contain in general. In lecture one, we discussed about consensus, proof of work, proof of stake. So what is consensus? Consensus in general refers to a mutual understanding or agreement between different groups of people who are neither connected or having different views over different type of things. And coming to proof of work is used by Bitcoin for maintaining the consensus and Sybil resistance of the network. What proof of work does is proof of work gives a cryptographic puzzle which asks miners to solve for producing the next block in the Bitcoin network. And proof of stake. What is proof of stake? In proof of work, a lot of electricity is used and a lot of energy is being wasted. To tackle that one and also to improve the speed of the systems, proof of stake is introduced. Proof of stake is one type of consensus mechanism where validators will stake some of the native currency of a particular network and get rights to vote on the block and mine the blocks. So here stake could be also referred as collateral, and compared to proof of work, proof of stake uses less amount of energy and it is more efficient. So coming to the next part, we discussed about cryptography and hash functions. What is cryptography and what is hash functions? Cryptography is a subset of maths which enables or which usually deals with chippering and dechippering of codes to secure and protect information. These type of mechanisms are mostly used in defense related purposes and also in security purposes where you want to pass the data but don't want to reveal the data to everyone. And what is hash function? Hash function is a type of function where you give some sort of input, it produces a sort of output which is unique to the given input, and no different input would give you the same hash. And in many of the hash functions, the hash you get would be of a same length. It would be a fixed length output hash function. And there are different types of hash functions, and different type of hash functions are also used in proof of work and proof of stake. Proof of work uses SHA-256 hash function, while proof of stake or Ethereum uses elliptical curves as their hashing thing. Elliptical curves and Keccak-256 as cryptographic and hash functions. So we can also say hash functions as one-way functions in some way. So what are one-way functions? So one-way functions. Now let's go on with an example. Take your pen and paper or a calculator. Make this calculation. What is 2 into 17? What is 2 into 17? It is 34, right? And what when multiplied with 23? It is 253. And what if I ask you to compute 2 square into 3 cube into 5? It is 8 into 27 into 5. 27 into 40, it would be 540. So this is easy. So now let's go on a back way. So what are the prime factors of 119? So if we put on a calculator or if we Google, we find it to be 17 into 7. And what is the prime factors of 7 into 11? What are the prime factors of 1001? Yeah, it is 7 into 11 into 13. So what are the prime factors of 2089? Anyone? What are the prime factors of 2089? So 2089 doesn't have any prime factors. It is a prime number and it is 1 multiplied with 2089. So this is a little difficult whether to know the number is a prime number or whether a number is a composite number. So what are the factors of 6, 1, 2, 3, 5, 8, 4, 7, 2, 6, 2, 6, 8? If you guys try to find out what are the prime factors of it, it would take us some time. And if I increase the total number of digits, let us say 200 digits, so it would be a very large number, and computing the prime factors of that very large number would be difficult. Given if it is a prime number, determining whether if it is a prime number or not is much difficult, given increasing size of a number. So, but what if I say that I give you prime factors and I ask you to multiply them? Getting a 100-digit number is easier or difficult? It is relatively easier compared to finding out the prime factors. Multiplying prime factors and finding a large number is easier than breaking down a large number and finding all of its prime factors. So we also have a discussion between what Bitcoin is and what Ethereum is. Usually Bitcoin can be referred as first blockchain and cryptocurrency, and Bitcoin is non-programmable blockchain, while Ethereum is the first programmable blockchain where you can host smart contracts and run your code. Bitcoin uses proof of work, while Ethereum uses proof of stake. So what is Ethereum? Ethereum virtual machine, smart contracts, and Solidity. So as discussed, Ethereum can also be referred as a superpowered computer where everyone comes in and uses it to do their respective tasks. And for using Ethereum, you need to have its own native currency called Ether for making those programs work or interacting with your smart contracts. And what is Ethereum virtual machine? So Ethereum virtual machine is where all the code of Ethereum is executed. It's something like if you are running a Java program, all your Java code is executed in Java virtual machine. So you can refer Ethereum virtual machine as a Java virtual machine made or changed according to the use case of Ethereum blockchain. And what are smart contracts? Smart contracts are digital agreements between people and they are immutable given their nature. So smart contracts are the way you interact with blockchains like Ethereum and using languages like Solidity and Viper. And coming to Solidity. Solidity is a language which is used to write smart contracts, and whatever smart contracts which are written in Solidity during the time of compiling would be converted into bytecode. As if when we write a C program, it would be a human readable code. But when we compile the C program, it would be converted into assembly language code. So that is the difference between, that is the analogy between Solidity and C and Ethereum virtual machine and some virtual machine which supports a programming language. So next, coming to the things which we discussed, it is DeFi and non-fungible token. So DeFi, also known as decentralized finance or digital finance, where money is being hosted on the smart contracts. Also, money is controlled or owned by the actual persons. It is not like a reserve bank, which has its own right to make your money valid or invalid. In DeFi, if it is your own money, if the money is owned by you, no one has right or no one can deny you from using that money. You can also say it as DeFi is something as an alternative to centralized finance or banks. So non-fungible tokens. What is a non-fungible token? If we talk about non-fungible token, we can say it as a unique token issued to a user depending on various use cases, which either may denote ownership of a particular thing or completion, or it may also denote ownership of a digital art or something special. So now we discussed about NFTs. And we also tried something in the last lecture. So what did we encounter in the last lecture while we tried to mint our own NFT smart contract and NFT? Yeah, we ran into a lot of issues. As a lot of people tried to mint smart contracts, there we ran into issues, and it is because Web3 infrastructure is still in its developmental stage. It doesn't reach its saturation level or a stage where there would be a minimal amount of issues. So while Web3 holds promise for many things and brings many new definitions to the world and enables new things to be done, it also has its own set of challenges like scalability and usability. Developer experience is one of the crucial part in Web3. While developing in Web3, many of the developers in their beginning stages would be hesitated to do things only because the development environment evolves rapidly. So now it is our turn contributing to the infrastructure. And so it is our turn contributing to the Web3 infrastructure. If you guys can pull it off, we can really make a valuable and valid contributions.
Hello, everyone. So I think we'll start with the second part of the lecture series, second part of this particular lecture, which is anatomy of a DApp. So whoever is in the meeting, I would request you to please be present and pay attention, because what we will do from now is gain a conceptual understanding of the overall architecture of a DApp. This will help you later on with the when you study about each component in detail, which will be provided in the readings for you, and then consecutively you will have the um, assignment, which will include building a DApp for yourself. So this is how the approach will be. So I would request you to please pay attention. So we'll start with the first part. So I understand that some of you may not be initiated into the Web2 architecture. So that is why I have put this slide. As you can see, this is the anatomy of a Web2 application. So on the right hand side, we have a schematic diagram of a traditional Web2 application. Now, this and all consecutive screenshots have been taken from Preeti Kesireddy's blog. So right, so moving on, as you can see, we have the user at the top and who is interacting with the application via a software called the browser. And the internet enables the communication with the web server, which is divided into three parts: the front end, the back end, and the back end communicates with the database. Right. So we can go into depth about all these topics, and that is what the text is all about. So I'll just quickly brush through the Web2 application. I mean, this slide should be pretty obvious to you if you are a Web2 developer, but so we'll go over it anyway. So the browser, as you can see, is the main point of access for anybody who is accessing the internet or any service on it, right? The service can include anything from WhatsApp, Instagram, Twitter to Reddit, and so on, right? So this is the gateway to accessing internet. And the browser is able to do this because it is able to communicate with different protocols. If you know, like HTTP, which is the hypertext transfer protocol, Tor protocol is another, and there's something called FTP, which is the file transfer protocol. So people who study about networks, they know about these protocols. But in essence, protocols are nothing but a sort of contract, right? A contract in a traditional sense, a contract between a user, like the end computer, your laptop, right, and the server, which is the other person's computer. So the protocol essentially establishes a method of communication between these two people, right? And that is what the browser is capable of doing. So moving on, the browser, that is what the browser does. And then the browser is able to access the front end of the application, right? Now the front end is the user interface. So every application has its own, just give me a second. So every application has their own interface, right? I mean, the Twitter interface is different from the WhatsApp interface and so on and so forth, right? And this is what the user interface defines. It defines the look and feel of a particular application. Since we are aiming on this lecture from the developer's point of view, therefore we will also talk about how these are achieved. These are achieved via something called scripting languages called HTML, CSS, JavaScript. There is also frameworks like React, Angular, Vue that are used. I mean, there are also other applications that are used, other frameworks that are also used. And moreover, the front end communicates with something called the backend, right? Using libraries called Fetch, Axios, and etc. And moving on, the backend is what contains the business logic of the application. So, for example, you might want to post a story on Instagram. So the application which is able to authenticate that it is you who is posting the story, then storing the image, then sort of counting the number of likes that it gets. All this is contained in the backend of the application, right? This backend also communicates with the database because there is some amount of data that you want to store across a large number of time, right? Across a large interval of time. For example, the number of followers that you have today should be able to you should be able to access it, like 2 years down the line. So that is something that you would store in a database. So I think these I'll move on to the next slide, but I think this gives you a very brief bird's eye view of the architecture of the Web2 application. There's the front end, there's the back end, and then there's the database. Now, one peculiar characteristic about the Web2 application is that it is a centralized application by design. And this is very important. And this is also what sets this apart from the Web3 application, which we will see in the next slide. The Web2 application by design is centralized because all this logic, the files that the code that you write for the backend, front end, and the database access code, everything is available. Everything is served via something called the web server. The web server is a centralized entity, right? You pay services like Amazon Web Services or Google Cloud Platform, Microsoft Azure, etc., to host your server, host your application, right? And this is where the Web2 application sort of faces a deficiency, because there is always a central point of failure. Moving on. Right, so I think this is what the database is about. So the data layer is, I'll also give some example of the database. So MongoDB, MySQL, PostgreSQL. These are some things that these are the popular databases that you will come across when you want to develop for a Web2 application. I mean, there is also something called third-party services, which is not shown in the slide, but the third-party services are able to enhance the features of your application by giving it certain capabilities. These can include things like, having a payment gateway in your application if you want to create an e-commerce website, or having authentication using something called Google Auth, where you do not need to enter the username and password, but it will communicate with Google servers to authenticate your identity, and so on and so forth. So these third-party services that you can integrate in your application to make your development flow faster, right? So I think these two slides cover the basic general overview of the Web2 application. And I've also pointed out the deficiencies, right, that are there in the Web2 application, such as a centralized web server and a singular point of failure. So moving on, we'll move on to the next architecture. Now, this is your first impression of a Web3 application. As you can see, we're introducing the SC. The SC is what is called the smart contract. I hope you have heard about this term a lot before, if you have read through the readings. So again, a disclaimer before I start this: architectures evolve every day because the Web3 ecosystem is a evolving field. But what we present here is supposed to be generally true. It may not be always true, but it depends on the use case that you are trying to build for. Now, one question I want to ask is, what is the major difference that you see here versus what we have seen before? I don't think, I mean, if it's possible, you can type it out. Maybe you can just, let's see. You can type it out if you wish, else I can just go ahead with the lecture. So I'll tell you what the major difference is. There is clearly a demarcation, right? There is a clear demarcation between the web server and the Ethereum blockchain, the red part and the blue part, right? So now this time we have the front end, which is being served, but the front end is not being serviced by a backend. Instead, there is this big chunk of Ethereum blockchain block, right? Now, in this particular slide, we will break down what this chain is about. So at the very what this block is about. So at the very base, we have the Ethereum blockchain. Now the Ethereum blockchain, as Manoj has already told you, and I hope you have gone through the readings, the Ethereum blockchain is a data structure which holds immutable data, right? The immutability of the data is ensured by the design of the system itself, namely via the mining process, which ensures that the history of data that is stored in the chain is what do you call that, is assumed, no, it is assumed to be correct by the majority of the population, right? It is agreed upon. It is agreed upon to be correct by the majority of the population, which is essentially what consensus is. Everybody agrees that Manoj and Basil had a transaction at 5 AM on a Sunday afternoon, for example. This is the sort of information that everybody agrees on, and everybody has a copy of the same data. This is what immutable data means, right? And the Ethereum blockchain is that data structure. A data structure is nothing but um, a way of organizing data in the computer's memory. Okay, cool. Now, the Ethereum blockchain is the equivalent of the Bitcoin public ledger. Now, let us break that down. What I mean is that there are a number of different blockchains. The Ethereum blockchain is one of the blockchain. There's also the Bitcoin blockchain. There are also something called Polygon, Optimism, Cardano, which we will meet later down in the lecture. So these are all different blockchains that exist. Each have their own different properties, but each of them also have abide by few rules such as immutability of data and so on and so forth. So that is what the Ethereum blockchain is. It is the data structure that holds immutable data. Now we see that there is the green block, which is the Ethereum virtual machine. Now this is exactly where the Ethereum blockchain differentiates itself from conventional blockchains such as Bitcoin. Because Ethereum is what is called data plus code instead of the original data blockchain. So in order to understand this, just imagine if you had the Bitcoin blockchain, the only thing that you would be able to do is agree upon a series of transactions that happened in somewhere and in a manner that is agreed upon by the majority of the population. But Vitalik Buterin, if you have heard of the name, he's the founder of Ethereum. He imagined a global computer where there are multiple different computers around the globe, and each of them are communicating with each other, and then agreeing upon not only a piece of data that is supplied by the user, but also a piece of data that is computed by the computers. Right. What it means is that the data does not have to sit on the blockchain just by itself. It can also be changed by certain code that is written, and the transformation, the result of the transformation can also be agreed upon by the majority of the population. And this, if you think about it, is a very powerful idea because it enables us to build a number of different interesting applications and give rise to what is effectively the Web3 ecosystem. Right. Cool. So moving on, I think the Ethereum virtual machine, I'll just give you a more technical definition of what the EVM is. So if you have, I think Manoj also touched upon this a little bit. If you have programmed in a language called Java, they have something called the JVM, which is the Java Virtual Machine. The Java Virtual Machine is itself a program that runs on a computer and it executes the Java code. Similarly, the EVM is a machine. It is actually a computer program that sits on the computer of anybody who is running the Ethereum node, and it executes something called Solidity code, which is the language in which the Ethereum code is written. Right. So moving on, what is the smart contract? Now, the smart contract is the building block of all major dApps today. What it means is that whatever code that the EVM executes is in the form of a smart contract that sits on top of the virtual machine. You can write a smart contract in any language, in any programming language, such as Solidity, Viper, Rust, and so on. Solidity by far, I think, is a popular first choice, but Rust is also gaining popularity due to its optimized workflow. Right, I think we have spent quite an amount of time in this. Moving on, let's look at a new addition to our architecture. Now what we have is, as you can see, there is this red block that has been inserted between our two blocks of web server and the Ethereum blockchain, which is called the provider. Now, what is the provider? If you think about it, the provider is supposed to ease the job of the developer, of the Web3 developer, in order to communicate with the Ethereum blockchain. So let us talk about something called JSON RPC. Please note that I will be throwing a lot of terms and words, so it is completely okay if you're not able to understand on the first try. We will also obviously be sharing the slides with you, so try your best to understand, and you can always refer back to the slide and build this picture in your own head. It is very important that you understand how the Web3 application differs, because the upcoming lectures and the upcoming assignments will demand that you build a dApp on your own. So we will obviously be providing you with other resources, but it is important that you have this bird's eye view of this overarching view of the entire application design. Right. So moving on, what is the JSON RPC? The RPC stands for remote procedure call. You don't have to know the full form. What it effectively does is it is a method of communication with any two entities on the internet via something called the JSON data format. So people who are aware of JSON data format, it is nothing but JavaScript object notation. It is a way of transferring data from one entity, one computer to another on the internet. Right. So the JSON RPC is extensively used to communicate with the Ethereum blockchain, and that is done via the front end. And some of the providers that you will meet in the market are Infura, Alchemy, and MetaMask. I think that you have already met a couple of them in the previous lecture, which is MetaMask and Alchemy. MetaMask also has a wallet. We will come back to the wallet later, but MetaMask is also a provider. It is important that you understand and are able to differentiate between these terminologies, because it can get confusing in the Web3 ecosystem. Right. Cool. I think we can. So just one more point I wanted to add on this. So what is the role of the provider exactly? The provider is able to give you methods and functions that you can access, that you can use to directly access data on the Ethereum blockchain and also communicate with your smart contracts. So maybe your smart contract has a function that you want to call from the front end. The Alchemy provider will provide you with functions and an interface that you will be able to use to communicate with your smart contract, right? Using the RPC protocol. All right. Let me just check if there is any doubt anywhere. Right. So I don't see any doubt. We'll move on. I think we're done with providers. Now we'll add the next block to our conceptual understanding, which is the client-side provider. So as you can see that the major difference here is that the front end is sort of communicating with this triangle on the side called a signer, right? So in order to understand what the signer does, we have to first understand what a transaction is. Excuse me. So as a user, that is the person on the top, the user is able to interact with any Dapp on the internet. Now, right, I think I forgot to mention, but a Dapp is nothing but a decentralized application. It is in the industry, it is shortened to a Dapp. So a Dapp and a Web3 app is the same thing. And as a user, you will interact with your Dapp by creating transactions. A transaction in a conventional market way is defined as an exchange of goods or services between two parties, right? And that is what is happening on the Web3 ecosystem as well, because the global blockchain contains a particular state, the state being, a particular history of transaction that has happened so far on the blockchain. Right. So for example, it may be that A has given something, A has given 500 rupees to B, B has given 200 rupees to C, and then C has given 200 rupees to A. These set of transactions are recorded on the chain and constitutes what is the global state of the blockchain. A state is, well, it's a state, right? Now, let's say if a person D wants to create a new transaction and interact with your Dapp, they will be able to make a new transaction. And if everything goes well, and by everything goes well means that the transaction is not corrupted or it is validated in time, it will be included in that set of transactions that we talked about earlier, right? It will be the fourth transaction in the history of the blockchain. And that is what is known as altering the state of the blockchain. How does the altering work? If you have heard about, I am pretty sure that you have read about proof of work and proof of stake. If not proof of stake, at least proof of work. And you know that there is a gamified economic competition that goes on between the miners to validate the particular whatever transaction that has to be included in the chain, which ensures the validity of the transaction. So it means that no fraudulent transaction can be included in the chain, and can be sustained. It may be possible that a fraudulent transaction is included in the chain, but that transaction will quickly be removed from the chain because the majority will not comply with that transaction, because the majority will flag that transaction as an invalid transaction. That is where the consensus, the power of consensus comes into play in the blockchain. So I think that was a bit of a deviation, but I think it was a good deviation. Moving on, what can a transaction be used to do? A transaction can be used to do literally anything on the blockchain, from borrowing money from somebody else, from minting or gifting NFTs, from even creating your own smart contracts or using some other person's smart contract which is deployed on the blockchain. All this is enabled by the transaction. Now, this is where the signer comes in. The signer is effectively the wallet that is used, that is the unit of identity on the blockchain. So just as we have accounts in the conventional Web2 application, I mean, I have an account, I have a Google account, I have an Instagram account, I have a, let's say, a Facebook account, right? The wallet is the atomic unit of identity on the blockchain. Now, the wallet is what stores value, such as, whatever ETH or whatever cryptocurrency that you have is stored in the wallet, and the wallet has the power to create a new transaction or interact with any other wallet on the chain. Right. These wallets, as you can see, starts with OX, which are hexadecimal addresses essentially, and can contain a varying number of digits, characters from 34 to 64 characters. That is not important. One thing of importance that you should note is that the wallet or the vault of value can be owned by the human, which is called EOA or externally owned accounts, or it can be a contract owned wallet, which is something that a smart contract may have. So any smart contract on the blockchain would also have an address, which is the address that you would use when you create a transaction with that. If you want to create a transaction with that blockchain, with that smart contract, I'm sorry. Right. I hope that is understood. I will also check if there is any doubt up to this point. Feel free to ask your questions in the live event Q&A. I'll continuously check this. All right. Moving on, I think we have a couple more slides, so I'll go a little bit faster. So, moving on, we have the IPFS. So if you remember, we had talked about the database, and we had discussed extensively how important the database is to the usefulness of the Web2 application. It contains all the data, right? It contains the user profile of multiple users. It contains, I mean, if you have an e-commerce website, then it can have product information, it can have order information, and so on and so forth, right? The IPFS is what is the Web3's database loosely. So if you look at our architecture, it has become quite extensive, but we have added this new cylinder called IPFS swarm. Now, what this is, the IPFS stands for the Interplanetary File System. The IPFS is a decentralized, again, it's a protocol. It is a decentralized protocol which is used to store information, which is used to store files. Files can be anything ranging from images, audio, video, and so on and so forth. How is this information stored on the IPFS system? The file is broken down into chunks. There is a deliberate algorithm that is used to ensure that whatever information you store is broken down into a number of chunks, number of small bite-sized pieces, and stored across the network in multiple different systems. So it means that if I have a file, it is not always stored on the Amazon's or the Google server. It may be stored on somebody's computer. A part of it may be stored on somebody's computer, and it may be stored in some other part of the world. And this is where you get the advantage of having a decentralized application, because you are not truly decentralized in the way that your information does not reside in one particular node. A node is effectively another server or computer on the internet. Sorry. So the information is not stored on one particular node, which means that your application is not truly decentralized. How does the requester, how does the person who has stored the file is able to retrieve the information back again? Now, this is again a bit more involved. If you want to understand how this thing happens, you can read through the white paper. which describes the algorithm in much detail. But to give you a basic idea, there is something called a health check mechanism where you are incentivizing other people to store a part of your file in exchange for storing other people's file on your computer. So it is a way of give and take in the sense that you are enabling decentralization for everyone, but you are also not becoming a burden on other people, right? On another person. And so that is pretty much what IPFS is. It is a wonderful tool for you, for us, for the Web3 ecosystem to use in our architecture. And one interesting fact, the IPFS was actually not developed with the Web3 ecosystem in mind. It was developed much independently and much before that. It was just that people figured out that it will be useful in this particular use case, and now it has become popular. As a developer, you will interact with IPFS using libraries called web3.storage. Again, I'm throwing words here, and it is important that you know about these terms so that you can go on and research about them on your own. But the web3.storage is a library that is used to interact with IPFS, and SORM is also another such protocol. Right. So the note is essentially what I have been talking about. It is the decentralized versus the centralized debate, where if you store your file on a centralized platform like AWS or Heroku, there's always the danger of it being changed or mutated by somebody who has power over those servers, right? I mean, there is this big debate about, the owner of X using the platform for personal incentives or some personal motivation. These kind of things are not possible by design in the Web3 ecosystem. And this is important to understand. By design means there is no possibility for a person to manipulate or change information on the blockchain, even if they want to, right? This is where the engineering part comes in. Cool. So I think I'll move on. Right. We'll move on to the next part, which is the graph. So just a second. So if you see, the change that we have added is this part on the left hand side, the graph, which is essentially what Google is in the Web2 ecosystem. It is a indexing and a querying protocol which is used for Web3 applications. It is not directly related to the developer for building dApps, but it is instrumental, and it is important that you understand what the graph is and other applications, other protocols in the Web3 ecosystem, so that you are able to build more robust Web3 applications. And yeah, so another fun fact that I would want to include here is that the graph itself is another smart contract that exists on the Ethereum blockchain. So, I mean, anything that you do on the Ethereum blockchain, any sort of information, any sort of global state change is enabled by something called these by writing smart contracts. Right. So I'll just check. Oh, just a second. I'll just check if there is any doubt. Hi, I'm back. So, right. So I think the graph is understood. We'll finally add one last. This is pretty much what one of the ways of arranging or one of the ways of visualizing your Web3 application or the dApp is. There may be other, there are possibly other ways also, but this is, I think, a fairly good way to visualize for a beginner. Right. So just one last thing we'll move on to, which is this big chunk of block that we have added, which is Polygon, ZK rollup, optimistic rollups, and the L2 scaling solutions. So this is what the third part of the lecture will be about, which is scaling solutions. And Ashish will be talking about this extensively, although I will give you a basic idea of what layer 2 is. So imagine this case where you have a large number of transactions that is happening on the blockchain, right? So as the network grows large, it is a reasonable thing to assume, right? Because there will be more people who want to transact on the network. Now, as there are more transactions, you understand that the gas fee will increase because the gas fee to validate your transaction will increase. Um, what this amounts to is that it will stop people from using your blockchain because uh, uh, because the gas fee is high. And this is in fact what happened with Ethereum uh, when it was on the proof of work method of validation, right? And this is where scaling is important. What the scaling do? It effectively ensures that the network is able to process a large number of transactions without increasing the gas fee to such a limit that it will become unusable, right? So how do you scale? There are multiple ways to scale. Uh, some of them include obviously changing the underlying protocol itself. So you can imagine Bitcoin sort of changing its fundamental code in order to become more scalable. Although it will have a lot of problem, as you can imagine, because there are a number of Bitcoin nodes running around the world, and to change every one of them to a different version, and to ensure that all of them are able to communicate with each other without any problem is again a big engineering issue. That is why uh, a workaround is to have what are called layer twos. What is a layer two? A layer two is essentially uh, a set of smart contracts or a layer on top of the base layer that provides the scaling solution to the base network. Polygon, again, if you have heard about, it's a famous Indian company, is the largest L2 solution currently. Other examples include Optimism, Lightning, and so on. Right. Uh, if you look at it from the engineering perspective, there are effectively there have been experiments with a number of different techniques. Some of them include sharding, plasma, and rollups. The thing is that rollups have been sort of advantageous, or it has been found that they are useful in general. Therefore, the industry is sort of leaning towards rollup as the go-to solution to scaling in the Web3 ecosystem. Right. As I said, the all the images that have been used in this presentation have been taken from Preeti's blog. Uh, with that, I think I come to the end of my part. Ashish will be taking over, explaining rollups from here. So thank you very much and see you. So just a second. We'll also be releasing the readings and the assignments. So I hope it works out.
Hi everyone, I hope you can hear me. Okay, so hi guys, I am Ashish and I will be speaking about and giving you an introduction to layer 2. So Basil gave me a very excellent segue. He explained you about the anatomy of a Web3 application and what a layer 2 essentially is, and I'll dive in a little further. So there are essentially three pillars of a blockchain. Those are decentralization, security, and scalability. And what the blockchain trilemma suggests is that at one point of time, you can only maximize two of these three things. And this was coined by Vitalik Buterin, who is the founder of Ethereum. And it hasn't been proved, but in practice, this has been true so far. It's possible that there comes a technology in future which is able to, maximize all three of them. But for now, we are only able to do two of them. So I have a question for you. So let's say out of these three, you're building a blockchain protocol, and out of these three pillars, you have to put your emphasis and maximize two of these things. So what will you choose out of these three? Please submit your answers in chat. Out of decentralization, security, and scalability, which two will you choose? Okay, so basically, the current protocols which have been developed choose mainly decentralization and scalability. Sorry, decentralization and security, which also makes sense. Like if you're building something on blockchain, you want it to be decentralized. Decentralized, that's one of the main priorities. And apart from that, you obviously want the security to be maximized, because these two are very fundamental concepts. And if these are not, like a blockchain is weak in one of them, then it defeats the entire purpose, right? So what they usually compromise is on scalability. So we need a way in which we can make the blockchain scalable. So I'll take you through an example. So let's say you have a highway, and on this highway there are multiple cars, and these are toll plaza. Now the toll plaza says that only X cars are allowed every second. Right. So I want you to think of the highway as our Ethereum blockchain, and the cars as transactions. So basically, what we're saying is that our blockchain only allows a certain number of transactions per second. And I wanted to remember this example because I'll come back to it after some time. So this is the current scenario in which you can clearly see that the transactions per second of blockchain networks is way lower than that of Visa or MasterCard or PayPal. And so essentially, we want our blockchains to compete with Visa. And currently, as you can see, the transactions per second is way too lower. And what that ends up happening is that the gas fees is very high, and it becomes a bottleneck. So you can't really expand it to a level that Visa has all around the globe, even if you want to. So what do you do in this case? We come to layer 2. So the main goal of a layer 2 is to increase a transaction throughput without sacrificing decentralization or security. So what the layer 1 provides us with is a network of node operators, a network of block producers, the blockchain itself, and the consensus mechanism. And layer 2, which is built on top of it, provides us a way to scale it, provides us a way to increase the transaction throughput. And essentially, what ends up happening is that you get a lower gas fees, but it still maintains security, and it expands the use cases, because now you can, with the lower gas fees, you can use it in a wide variety of scenarios that you could not with a high gas fees. But how is this possible? So let's go back to our previous example. And we were discussing about the problem where you had multiple cars, but only X cars could go per second. And we want more people to be able to go through the highway. So what we do is we club multiple people into one car. So instead of 3 people going in different cars through a toll plaza, what we do is put these 3 people into one car, and then we are able to send more people through our highway network. So the analogy in Web3 sense is a roll-up. So what roll-ups do is that they bundle transactions into a single transaction, and then they submit it to layer 1. So essentially, they are referred to as off-chain transactions. What would do is that you would transact in the layer 2 network, and they have a higher processing rate. And what they do is that they take multiple transactions, and and then they bundle it up, and then you put them in layer 1. So you're able to basically send in a lot of transactions bundled up into one that you were not able to do so earlier. And the two main approaches that we use today for this are optimistic rollups and zero knowledge rollups. The example of optimistic rollups are Arbitrum and Optimism. And for zero knowledge, there's Polygon is a very big player in that. And apart from that, you have Starknet and ZK Sync. And they both have different approaches as to how they bundle this up. And the main goal is to reduce the data that we're putting on the main layer 1 blockchain. And how you do it is a different approach in both of these. So yeah, like this will go beyond the scope of this video, but we have put in additional materials for you to read about both of these, and it's very interesting as to how both of these methods work, and they're completely different. So I'll suggest you guys to read into it. It's very interesting. And apart from rollups, there are other ways that you can improve and tackle the scalability challenge. And those are side chains and payment channels. And you could read about those as well. And for layer one also, that there are some ways in which you can increase scalability, and there sharding comes into play. And you should read about sharding. It's a little advanced concept, but it's really interesting to see how it all works out together. So now I'll call Manoj, and he'll tell you about the different resources and how the assignments are for this lecture. Manoj? Stop. Last.
Hey guys, this is the end of our lecture. And in the resources page, you can find our course website, reading materials, assignment 2 and quick links. We would be sharing the recording later and also the reading materials and assignment in a while. So thank you. Happy coding.
Captain the clear